Alright. Let's do it. Easy peasy ones. Antiderivative of x to the n, 1 over n plus 1, x to the n plus 1 plus Charlie. Hopefully nice and easy. Other easy ones. What other easy ones we got?
Number 2.
Number 2, antiderivative of 1 over x. Everyone's going to tell me?
Natural log absolute value of x plus.
Okay, plus Charlie. Other easy ones. Take anything from anybody. What do you say? Easy ones. Jasmine.
Number 5 is 2 over 5x to the 5th over 2.
Okay, so is it because you found that one on the front?
No.
Oh, okay. What did you do?
I thought I remembered it.
Okay. Alright. Finding it from the front, that's fine. But for those of you that are like not going to remember tomorrow, what would you do? You're in the middle of the test tomorrow. What would you do? Nora, what would you do?
Get the exponents for each one. So rewrite x is x to the first power, and then the square root of x is x to the 1/2 power.
Okay.
And then,
so we've got x to the first times x to the half.
so
and then?
you would add 1 to the exponents. So then it would be.
Ooh, I was afraid you were going to say that. Not with multiplication. If there is multiplication in the anagram, you don't just add 1 to the exponent and add 1 to the exponent. Multiplication and division are bad news. The reason, Nora, you rewrote x to the first times x to the half for a reason. What's the reason, Eunice? You can add those exponents together to get x to the 3/2 dx. Now that you've got one exponent, there's no more multiplication or division. Now we're going to add 1 of the exponents, so 3/2 plus 1, 5/2. Divide by the new exponent, which is 5/2, so that's really the same thing as times 2/5. So this is the mistake that I made on the front that I should know much better than that. Okay? Other quick and easy ones. Jennifer.
Number 6.
Number 6, what's the antiderivative of e to the 5t?
1/5 e to the 5t.
1/5 e to the 5t plus Charlie, of course. Other easy ones. I'll take anything from anybody. There's at least 1 or 2 more that should be like, you see it, you know what to do on site. Oh, I'm a little worried. A little worried. I see Nora, I see Jasmine. Noemi, any other ones that you think are pretty easy?
Number 3.
Number 3, okay, tell me about number 3.
1/6 t to the 6
1/6 t to the 6th
plus 4/3 t to the cube
plus 4/3 t cubed. I'm with you so far. We got that one, we get that one.
minus 2/3 t to the 3
Minus 2/3 t to the 3/2. Great.
plus c.
Plus c. Oh, you fell for it. Are you seeing that square root of 11 and saying, oh, square root of 11, it's a constant. And the derivative of a constant is 0. What's the mistake here, David?
X value, and so it would be 2/3 square root of 11x.
Oh, God, no! The square root of 11 is a constant. Abraham, help me out. Yeah, Abraham.
Multiply times t.
Right. Square root of 11 is a constant. The derivative of a constant would be 0, but the antiderivative of square root of 11 is just square root of 11t, and then plus Charlie. Now, 7 and 8, even if you didn't have enough time to get there, I'd hope that these are the ones that we can do on site. Antiderivative cosine 3 theta is 1/3 sine, careful, 3 theta. With the trig functions, the angles never change. The angle doesn't change when you take a derivative, and it doesn't change when you find an antiderivative. It stays the same all the time. Okay, plus I need the antiderivative of 3 times cosine theta. 3 sine theta plus Charlie, and maybe hopefully this one not too bad either. Right, hopefully we're looking at this and we're saying, oh, I know that pi over 4, that's just the constant, right? That's the constant that I'm multiplying by. And the way that I'm supposed to do an antiderivative for sine is it's, what, negative 1 over pi over 4 cosine pi over 4t plus Charlie. And if we're looking at multiple choice, they're not going to show you -1 divided by pi over 4. You know what they're going to do. They're going to say -4 over pi cosine pi over 4 t plus c. Okay. So here's what I want to do. I want to split the group a little bit. But I want you to split not based on are you fighting for a 5 or thrilled with a 3. I want you to split based on your comfort level with integration by substitution. I want to give you guys basically the next 15 minutes or so to get some practice with integration by substitution. If you're like, I've got this, I just need some time, there's a great model problem for you to follow along with, and then on the back, some practice problems. If you're just going to go like straight to that, where are those folks? I see Jennifer, I see Jasmine, I see the ladies over here. Why don't you all move over to the white table? Okay, folks that are going to stay with me, we're going to do one problem together from start to finish. But folks that are going over to the white table, you're just ready to fly. There's this model problem at the top, followed by some practice problems on the back. All right. Anybody else feeling the desire to move? Okay, so all the friends are with me for integration by substitution. Thank you. Okay. So, integration by substitution. It's been a long time since we've talked about integration by substitution, but the big idea with integration by substitution is the uglier the integrand is, the more likely substitution is going to be the way to solve this problem. I said that really poorly. I'll have to edit the video later. I've got an integral. I don't think any one of you just looks at this and says, oh, sine 2x over 3 cosine 2x plus 4, I've memorized that. No. No. Pretty ugly integral. Really ugly integral. This is why we do substitution. So if you're going to do substitution, have a conversation with somebody near you. What's your move? What's your plan here? Don't talk to me. Talk to them.
No, yeah, that's right. You can have all sides. Close down to the cosine. But it would have to be negative cosine.
All right, Edgar.
Yes.
What are your thoughts here?
Substitute the sign for cosine.
Substitute sine for cosine.
Maybe.
Usually the first thing that we think about when it comes to integration by substitution is what's the baby, right? What's that u?
Maybe.
And places that we would look for the baby?
Parentheses.
Inside parentheses. Other places, Rumbeer?
The parentheses,
Well, we already said parentheses. Other places we'd look? Exponents, denominator, where else? Radicals, underneath the radical sign, sometimes up in the exponent. There is a probably pretty obvious place where we're going to look here for the baby. I'm probably going to go for the denominator if I think that u is this 3 cosine 2x plus 4. Okay, my next move? Take the derivative. Take the derivative with respect to x. And you've got to be careful here. The derivative of 3 cosine 2x plus 4 is going to be negative of 3 sine 2x times 2. Right, we're taking the derivative here, not the antiderivative. So you could clean this up and say, all right, well that means that du dx is equal to negative 6 sine 2x, not too bad. I think with your class what worked really well is when we would just say du is negative 6 sine 2x and put the dx over here. If you're going to do substitution, the goal is rewrite this integrand so that it is easier for you to work with. And we've already handled part of that, because no one's going to talk about 3 cosine 2x plus 4 anymore. That's your baby. What about sine 2x dx? Sine 2x dx, what do you replace that with? And why? Martyr, what do you do?
I'm not sure, but are you supposed to multiply by the negative 1 over 6?
Right, if du is equal to negative 6 sine 2x times dx, and what I have in my integrand is sine 2x dx, then what you need to do is replace that sine 2x dx with what it's equal to down here. Right, so some people think about this as they multiply both sides by negative 1/6, and so they say, oh, negative a sixth of du equals sine of 2x dx, great. Other folks say I'm going to divide both sides by negative 6. Same thing, no big deal. Either way, your goal is you're going to rewrite the integral that way, which is now much easier to work with, much more likely that you can just attack, but we're not done with the substitution yet. Why?
You have to plug back in.
Christian, what's the problem?
You have to plug it back in.
What do you mean plug what back in?
You have to plug in the value for the equation.
Well, I'm not going to replace the u yet. That's too early. The reason that we're doing this substitution is to get something that's going to be easier to work with. There's something else. Jonathan, what's the mistake?
You have to find the antiderivative.
Well, you still have to find the antiderivative, right? That's what that sign's there for, but there's a big mistake. Edgar, what's the big mistake?
Instead of the negative 1/6, couldn't you flip it since it's on top of the function?
Well, you can take that negative 1/6 out. Okay, I think
Oh.
I'm being too vague here. It's been too long since integration by substitution. When you do substitution, everything changes. Everything over here was in terms of x. Over here, everything needs to become in terms of u. So Juan, what's the big mistake?
The points of integration.
The limits of integration have to change. They have to change. So if x is equal to 0 and x equals pi over 4, I need the new u values. U is 3 cosine of 0 plus 4. U is 3 cosine 2 times pi over 4 plus 4. Cosine is 0, you need to know that. Cosine of 0 is going to be 1 times 3 is going to be 3 plus 4, 7, okay? 2 times pi over 4 is pi over 2. If I think about my unit circle, cosine of pi over 2, it's going to be 0 times 3 plus 4, 4. So x used to be 0, now it's 7. X used to be pi over 4, now the u value is 4. That is a much easier integral for you guys to work with, and I bet most of you are at the point, you're like a step away from being done. So that negative 1/6, that's a constant I heard earlier, I can take that out. Negative 1/6 the integral from 7 to 4, 1 over u du. Daisy, how do you feel about the antiderivative of 1 over u du? The antiderivative of 1 over u du, what's that going to be? Oh. 1 over u du.
1 over x.
It's a lot like 1 over x dx. So the antiderivative is?
The natural log of the absolute value of x.
There you go. Natural log of the absolute value of u from 7 to 4, and you get the negative 1/6 in front. Plug in the 4, negative 1/6 natural log of 4 minus negative 1/6, the natural log of 7. That's a great answer. Don't have to do any more with that unless you really want to and you want to walk on the wild side. Don't walk on the wild side. Okay? So, if that is enough of a review for you, great. There's still about 5 or 6 minutes. There's some more practice integration by substitution problems on the next page that I want you guys to work on. If you need something that's going to make you feel good about yourself, maybe you want to try number 1 or number 2. If you want a challenge, try any of the other ones.
So
If you need to feel good about yourself right now, if you're feeling tender, try 1 or 2.
Stability.
Do we only take what's inside the parentheses or the exponent? Usually,
It's just gonna be what's inside the parentheses. And the way that you know that you picked the right baby.
it doesn't work in your socket. It's like, oh, you can't take the place of your hand. That's why I need to
Then it's not hurt.
No, because you see it coming, so you
Derivative of the baby. The baby is in the area.
Don't hurt.
you saw that coming.
Have the derivative of the baby or some like
What
multiple.
did I get my hand on it?
So that's how you know you picked the right baby. Alright, so what are we picking for the baby? Come on now, be careful. And you take the derivative, x1 is become small.
Gravity. So then do you
From the viewing substitution, I have to pay attention to the original
X squared.
limit. The original lower limit at x equals 0. And when I figured out what the u value is, it's 7 on the bottom side. The top limit was pi over 4. When I did the change, the top value became 3.
Oh, I don't know.
So I've got to maintain yours. But if you wanted to, you've got to flip, you've got to change those limits of integration. And what happens if you change the limits of integration?
Well, I mean, you didn't even know.
Right. The answer, like you wind up having to take the right. So like way back in the day when we were talking about integrals, it said like if you want me to find the area going from the left to the right, from small to big, and you get a positive answer, when you take the integral in the opposite direction, you get the opposite answer.
You drop the exponent.
Do you
You just like take off
the derivative
the
is
so it would
how
be
many?
6.
6x squared.
Yeah, I think that's what they did. Exactly.
Du.
That's how I made it.
U equals 2x cubed.
Oh, yeah.
And then you multiply times 1/6. Because you're supposed to get just x squared. Oh wait, it's this, isn't it? What
Yeah,
about?
that's what you're trying to get.
The negative 8x, that's good because I'm still at that x. Okay, friends, how are we doing over here? The derivative of 1, since 1's a constant, the antiderivative of 1 would be
So are we gonna have to do the box? Do we do the box?
Why would you do
But
that?
it's to the fifth.
Leave it alone. It's just u to the fifth times the 1/6.
But you're supposed to find. Yeah, but you're supposed
Just
to.
leave it alone. Now find the antiderivative. What's the
Oh,
antiderivative?
1/6.
Check the 1/6 out. You can factor out 1/6
No, I know, but what?
So now
No,
we're back over here and we're saying my goal
1/6
is to
u to
make
the
this
fifth.
equal to
Yeah.
Look, you can factor out 1/6, right?
So I'm not gonna describe this as
So now
2x
find
cubed minus
antiderivative
1
to the
fifth, I have a better way to call that.
160.
And I'm not gonna say x squared dx because it turns out to be
And then this one's all. Ooh, when he's smart.
Yeah.
Wipe him.
I'm trying to do substitution. I want to change this integral from being x's.
Another shorter one?
So instead of x squared dx, I'm going to replace this with.
Why would you put it there?
X squared dx.
This looks cool.
Yeah, but it doesn't make any sense.
I mean, I can't put in my eye, Nora.
Why don't you put something else? That actually makes the long. You should do that.
It's going to be 1/6. Hi, what can I do for you? Okay, thank you. After class, I like it. You figured it out. Yeah. So you're going to say instead of x squared dx, 1/6.
I have gastritis and I have the bacteria. I don't know what it is. The doctor just called yesterday.
So it's just
There's a lot here that I like. There's a little bit that I don't like so much. How did you go from here to here?
That's like 10 minutes.
Yeah. Okay. 1/2. So, 2x minus 1 to the 5th.
That's what you want, right?
And you're right about 1/6.
Oh, that's the answer.
Would you get it for the first one?
112 parentheses 2x cubed minus 1 to the power of 6.
112?
And that
Is it wrong? Because you have the 1/6 from multiplying from here. And then the other 1/6 when you get the antiderivative. Yeah, that's a constant.
You're right. You need to show people.
Oh, you didn't do the fifth pound. This is a winner?
No, I said yes.
Do we stop recording? No, like it's still recording. Gotta stop it? To my face? Really? No, what was
You're supposed to fix it whenever.
Oh,
That's
my
what I
bad.
told you.
Oh, well.
Why'd you do
1/6. Guys, you're replacing.
Oh, it's
No, it's like square.
Right? Because you must
No, that's
Times.
That's 1/6.
question.
alright, so you with definite integral. Where to go?
These intervals are easy.
Alright, I cannot believe we only have 10 minutes left. Where does the time go? Where does the time go? Alright. I will tell you, I spent a couple hours this morning with my friend Miss Blakely at East End, and I was scoring exams with her. We were looking at the multiple choice, And there are lots of questions on the multiple choice and on the free response that involve integration. Integration is a thing. We've got half the year on this. But rarely are the questions just going to be, hey, what's the antiderivative of x squared dx? Rarely is that going to be the situation. Much more likely that things start showing up in application problems. You're going to need to use the fundamental theorem of calculus, which involves integration. What is the fundamental theorem of calculus? Patiently waiting. What is the fundamental theorem of calculus? 21 individuals ought to know this. Nora, what's the fundamental theorem of calculus?
The integral from A to B
Integral from A to B
of f prime of x
of f prime of x
and g of x equals f of b minus f of a.
Okay, not quite the way I thought you were going to tell it to me, but that works. Probably the other way you've got it in your notes says that f of b equals f of a plus the integral from a to b f prime of x dx. Final value equals initial value plus the total change. Gonna happen a lot. Second fundamental theorem of calculus. Who's got it?
I think I got it. No wait.
Second fundamental theorem of calculus. I'm gonna wait till there's like 6 hands up in the air. Second fundamental theorem of calculus. Maybe it's on a poster, it's in your notes, use this time wisely. Gonna wait till there's 6 people. I see 1, who happens to be named Juan. I see Edgar. I see Martyr. Second fundamental theorem of calculus. Martyr, what you got?
d over dx.
Okay, d over dx, the derivative.
The integral from a
Of an integral. From a to where?
x
A to x.
ft
F of t.
dt
dt, what happens?
equals fx.
Equals f of x. The derivative of the integral of a function from a constant to a variable, you get the original function back. Great. Average value of a function is going to happen as well. Average value of a function. Average velocity, average rate, average anything. Jasmine.
The integral from A to B
Integral from a to b.
of a function times b
Yep.
of x over b minus a.
Over b minus a. That's one way that it's going to show up. The other way that it's going to show up would be 1 over b minus a, the integral from a to b, f of x dx. Great. 3 places right there where we're going to get integration. Integration also shows up in area. So if I gave you some curve f of x, whatever it is, it doesn't actually matter what it looks like. And I say, here's x equals a, and here's x equals b. Hope this is an easy one for all the friends in the room. You want to find the area. What are we going to do? What's your setup one?
Integral from a to b.
Area is going to be the integral from a to b.
F of x dx.
F of x dx. And then, right, because you know how to find antiderivatives, you're going to find the antiderivative. We're going to evaluate. Done. Lots of points come down from the sky. But maybe we're dealing with the area between 2 curves. This is area between 2 curves, f of x and g of x, where f of x is greater than or equal to g of x. So here's some function f of x. Here's some function g of x. I want that area. I see Jennifer. I see David. I see Edgar. How am I going to find the area here? Jennifer, what are you going to do?
The integral from A to B
Area is going to be the integral from a to b.
of f of x minus g of x dx.
F of x minus g of x dx. How did you know to do that?
Because top minus bottom.
Right, we're doing top minus bottom. Now I'm going to assume that the A and the B are those intersection points. Right, so we're just imagining a little slice going this way, top minus bottom from a place to a place. We're done, we're okay. Just focusing on the setups. All right, there are 3 integration formulas when it comes to the world of particle motion that you need to know. See what you can do with these next three. I will tell you, you'll be sending me little thank you notes after the free response part of the test tomorrow.
So is that you telling us to concentrate on this?
No, I would never tell you guys something like that. Y'all don't listen anyway, so. Yeah, just saying. Just saying, these things could be important.
Isn't this physics?
Yes, it is physics. And calculus. Displacement. I don't want to get these confused. There's a difference between displacement, total distance traveled, and position. All three involve integration. If you're in AP Physics, you're frozen out of the conversation for just a little bit. Displacement. How do we find displacement? You know velocity. How do you find displacement? I see just Jennifer. There's 21 young adults in the room. Displacement. How do we find displacement? Ron Beer, how do you find displacement?
Isn't it just the integral from A to B to V?
It's the integral from A to B, v of t dt. Done. That's it. Displacement integral of velocity from A to B. Total distance traveled. Totally different. Jasmine. Integral from A to B. Absolute value v of t dt. Total distance traveled. You need those absolute value bars around your velocity. And if you put absolute values around velocity, what do you really get? What you really get? Absolute value of velocity is? Absolute value of velocity is speed. Speed. Okay, position. You know the velocity of a particle, or a cat, or a rocket, whatever it is. You also know its initial position. You know the velocity. You know how fast it moves. You know where it starts. How do you find the position at time B? David.
The initial condition of x of a
You take the initial position
plus definite integral of absolute value of dt.
definite integral from A to B, and what's the function?
Absolute value of dt.
Oh! Would you like to rethink your answer? How about not involving the absolute value bars here? Because the integral from A to B of v of t is displacement. It's change in position. X of A is where did I start, plus how much did my position change. That's where I end. All right, volume. These are the last three. I hope we can get these last three down here. In a minute. It won't take long. Volume. We just did volume. Just did volume. So I've got some function f of x. Here's f of x. Don't know what it is. Don't even care what it looks like. Here's x equals a. Here's x equals b. Spinning around that x-axis, what's the volume? Jose, what's the volume? Definite integral from A to B. Wait, one more time? F of x is the name of the function. F of x dx, I do not agree. Do not agree. Volume. Imagine this guy spinning. You need pi. Okay, and this guy here, just real quick so you can get it down, you'll thank me eventually. Okay, here's f of x. Here's g of x. Here's some function from A to B. Oh, I didn't mean to draw it that way. Like there. Taking that little region, spinning it around the x-axis, the question that we would always ask back in the day.
All
Hollow or solid? And the answer here?
Hollow.
Hollow. So if it's hollow, you're going to say it's pi, the integral from A to B. You find your big radius. There's big R. You find your small radius. So it's f of x, the whole thing squared, dx, minus pi, the integral from A to B, g of x, the whole thing squared, dx. That's as far as we needed to get to, so I think we're going to be okay. Okay? Seriously, 1 hour tomorrow morning, going over formulas, making sure things are clear. Good idea. The 2-a-day session starts at 4:15.